Okay, this is just a look at one of the most recent provincial exams, in particular the questions from the physical science section, the chemistry section, that are from this section, this unit that you are working on right now. So again, in terms of you taking mastery of your own learning, the more of these kinds of questions you can look at, the more confident you should feel about the information. You want to get to the point where it doesn't matter how many questions we throw at you, you are confident in naming them, right? So if you take a look at number 25, the Bohr model shown here represents an atom of, well, what I would do is I would look at this. In the nucleus, you see 13 protons. And if you look at your periodic table, you're going to see that 13 protons is aluminum. Right. And of course you could come up with the same answer by just counting the numbers of electrons, because this is a neutral atom. You will see you have 2 in the first shell, 8 in the second, and that leaves those 3 in the outer shell. It is, yea and behold, aluminum. So, number 26, how many valence electrons do atoms of this element have? The valence electrons are, of course, the electrons in the outer shell. So if we count, we've got 1, we've got 2, we've got 3 valence electrons. The reason that that matters, of course, is it's those electrons in that outer shell, that valence shell, that actually participate in chemical reactions, either in an ionic bond or a covalent bond by sharing. Right, moving on to number 27, use the following Lewis diagram of an unknown element, X, to answer. So I'm looking at an element that has 1, 2, 3, 4, 5, 6, 7 valence electrons. Right, we should get a pen that's actually working here. So I see 7 valence electrons. If I look at my options here, which of the following Bohr diagrams represents the atom shown in the Lewis structure? These are, of course, Bohr diagrams. If I look at just the outer shell, I see 1, I see 2, 3, 4, 5, just 5 valence electrons. So we know it cannot be A. Let's check the one below it. C, 1, 2, 3, 4, 5, 6. 6 valence electrons. It cannot be that. Let's go over here to B. 1, 2, 3, 4, 5, 6, 7. Ah, sounds good. Except, look what's happening here. There are there's 2 electrons missing from the inner shell. There has to be 2 electrons in that shell in order to have the 7 in the second one. You wouldn't fill up the valence shell before filling up the first shell. And that, of course, leaves us 8, which is, of course, the correct answer. 1, 2, 3, 4, 5, 6, 7 valence electrons. Okay, number 28 has been known to scare people. Be not afraid. We have 3 options. We're given this lovely Lewis diagram, and there's something in the center, and then we have 3 atoms on the outside. That's going to be tribromide, trifluoride, or trichloride. We have to decide which of the other possibilities there are. So what I would do is I'd initially write the formulas. I mean, I see a name, oxygen tribromide. So oxygen tribromide. 3 bromines as a subscript. Well, nitrogen trifluoride, nitrogen trifluoride, and phosphorus trichloride. There you go. And then we want to make sure we have the right number of electrons. So if you actually add up the number of electrons, oxygen, you'll see, has 6 valence electrons. And if you have no idea how I came up with that number, you should talk to me, because it's not that hard to find out. It's in group 16. You subtract 10 from that, you're going to get 6. Of course, you could just go right along the period, and you'll see that it's 6 in from group 1. But we don't just have oxygen here. We've got 3 bromines. Bromine has how many electrons in its outer shell? We're going to have to add those. So there's 3 bromines with 7 electrons in its outer shell. We therefore have 27 electrons. And if we look at NF3, Nitrogen is in group 15, so it has 5 valence electrons. And of course, fluorine still, surprise, surprise, has 7 electrons in its outer shell. You have 3 of them, so the total would be 21 plus 5 equals 26 electrons. And then phosphorus would be also in group 5. Now that's interesting. The fact that both 2 and 3 are in the same group suggests that there's probably 2 answers to this question, right? And we still are dealing with a halogen here, the same group as fluorine, so it's also going to have 7 valence electrons times 3, total of 26 electrons. So if you go back and actually count the electrons here, 2, 4, 6, we got 6 right there, plus 2 here, plus 2, plus 2, plus 2, plus another 6, plus another 6, you are going to notice something. 6 plus 6 plus 6, 18, 20, 22, 24, and 26. So guess what? It has to be 2 and 3. Nitrogen fluoride and phosphorus trichloride. In other words, option C, 2 and 3. I almost, you know what, you should, to really be confident about that, you probably want to try actually drawing it with one of those. So for instance, we would take nitrogen, and we said there was 5 valence electrons. Just so you can keep track of these here, I would use X's for nitrogen, distribute them evenly around the nitrogen, and then you know you would have 3 fluorines. So each fluorine we will put like so, and each fluorine of course has 7 valence electrons. 1, 2, these of course are the non-bonding pairs, but the 7th electron in each case would be of course drawn in right here, and now we have a full valence shell for everything. So it works. The answer is C. All right, another question that when you look at it for the first time, your brain says, no, I'd have to think. I don't want to think. Have mercy. No, it's not that bad, really. You got 4 little test tubes, and you're really just trying to identify which of these test tubes would give the results in the table. So specifically, they say during an acid-base lab, and as soon as you read that, you say to yourself, aha, I'm going to need that lovely page of the pH scale from my data booklet, because you cannot do this kind of thing just in your head. Like most of the questions on the provincial exam, you need that data booklet. So this is an acid-base lab. 2 lab partners place 10 milliliters excuse me, of an unknown solution in each of 4 separate test tubes labeled A through D. There they are in the picture. They added methyl orange, bromothymol blue, phenolphthalein, and indigo carmine to the contents of the test tubes as shown in the table. The resulting colors are also shown in the table. The question is, which of the following substances would give the results shown? So, test tube A is being tested with methyl orange, and if you look on your table of the pH scale from your data booklet, you're going to see for methyl orange that methyl orange is in fact yellow. So we would say that soap actually works as a possibility. Then we might try the bromothymol blue. If we take a look at the bromothymol blue in test tube B, yea and behold, it is in fact blue, and on my table again, bromothymol blue is blue for soap. So again, that is a possibility. We are on a roll. Let's move on to phenolphthalein. Can you say phenolphthalein? You should try to say phenolphthalein. Your mommy would be so impressed if you could say phenolphthalein. Okay. Now that Mr. Powell is finished with that announcement, let's take a look at soap and phenolphthalein. They say that phenolphthalein is going to be colorless. But that's not the case at all. It would actually be pink. So we cannot say that that is true for soap. If you check indigo carmine, you'll see that indigo carmine is also true for soap. But guess what? 3 out of 4 just ain't gonna do it. So let's move to a different option. Let's do the next one, eggs. So again, you're looking at your table from the data booklet. Methyl orange for eggs is yellow, and that is exactly the color you would expect for methyl orange. So I would say, yeah, eggs is a possibility. Then I go to bromothiamyl blue. Bromothiamyl blue turns out to be blue in the test tube, and guess what? Bromothiamyl blue should be blue for eggs. Love eggs. Phenolphthalein should be colorless, and yay and behold, eggs show that they are colorless at that pH. And of course, indigo carmine should be blue, and for eggs, yes indeed, for soap, not for soap, for eggs are blue. We have an answer, ladies and gentlemen. It is eggs that will have those 4 results. Number 31, I would say this one is slightly easier. Which of the following substances has a pH greater than 7? Of course, pH greater than 7 means we are talking about a base, right? Hydrochloric acid, HCl. This, of course, is an acid. Did I say acid? Yes, I did. So acids, as you know, have a pH which is less than 7. That's not what we're after. We're after with something with a pH greater than 7. Has to be a base. When I scan the list here, I immediately notice the polyatomic ion hydroxide. When you see hydroxide, you know you are dealing with a base. And as you know as well, bases always have a pH which is greater than 7. That tells us that the answer is D. Just in case you're curious about these two are salts, and their pH is going to be neutral. Right. You will be pleased to know that this one is the last one. Number 32, which of the following compounds, when dissolved in water, that's interesting, will turn blue litmus red? Something that is going to turn blue litmus red, ladies and gentlemen, has to be an acid. Check your table again in your data booklet. Talk to me about that. The lovely little page in your package that had to do with metal oxides and non-metal oxides. This is where this one comes into play. You will notice that this is a non-metal oxide. Non-metal, nitrogen, combined with oxygen, makes this a non-metal oxide. There's another oxide here. This is, as you know, sodium. Left side of the periodic table, it's a metal. So sodium oxide is a metal oxide. Somewhere in your long-legged life, you are supposed to have come up with the wisdom that metal oxides are going to be, hang on a sec now, metal oxides are going to be bases, and non-metal oxides are going to be acids, which is, of course, what we want here. Just in case you're curious, B and D are both bases. Right, sodium hydroxide, strong base, ammonia, base. So there you go, you're good.